Okay, Mrs. Monroe and I are going to explain Meselson Stahl all the way from Virginia Beach in America. So, Meselson and Stahl had grown up a colony of bacteria in a medium, a food source that only contained heavy nitrogen. Nitrogen comes in two forms, isotopes, so heavy is N15 and light form is N14. So they exposed this bacteria just to heavy form, N15. So therefore they knew that all of the DNA, all the nitrogen containing compounds in that bacteria would have contained heavy nitrogen. So what they did then was they extracted the DNA from this colony and they centrifuged it, which was spun it around in a high speed, and this is what came out. So this was their 0 minutes sample, and they got a band at the bottom of the centrifuge indicating that it was heavy DNA because it went right to the bottom, and therefore each strand in the double helix was N15. So it's N15, N15, two heavy strands, but they immediately had put that bacterial colony into a different food source, a different medium, growth medium, which contained only N14, so only light version of nitrogen. And they knew that bacteria replicated every 20 minutes, so the next generation, with the only nitrogen available to them was the light N14. So we know about DNA replication, and the DNA double helix unzips, and the bases are free then, or well exposed, and base pairing can occur, but these new bases only have N14 in them. So there is our semi-conservative replication, where an original strand is kept into each new molecule. And now we've got two double helixes there, and here's our 20 minutes picture after they took a sample after 20 minutes and centrifuged, and they got a new band. Now it wasn't at the bottom because it wasn't heavy. This was now further up because the double helix contains one strand N15, the original N15, but the new N14. So therefore each double helix is kind of a mix of heavy and light, and that's why the band was there and not right at the bottom. So they let another generation appear, give it another 20 minutes, and let's unzip our double helixes there so that we can get more. And again, the only nitrogen available was N14, so there is a new strand synthesized. But look, we've got two double helixes that are only made of N14. So now we've got four double helix molecules, two of which are N15, N14, but we've got two more which are just all light. So if we go back to what the centrifuge showed, we have a new band right at the top because this was light DNA, because each strand was N14. So after 40 minutes they had a band right at the top which was N14, N14, light, and they had that band in the middle which was the mix of the heavy and the light. And as time went on, this band at the top, the intensity of the colour got really strong because all new DNA was N14, so these kind of molecules got more of those, and the only double helix molecules containing heavy were these ones. So that band there got not very...
less intense.
Yeah, it got less intense in comparison to the top one as time went on. So that showed semi-conservative replication, that each time one of the original strands was kept into each new molecule being formed.
So it was acting as a template, and then the new nucleotides were adding on to that. So it's semi-conservative.
Brilliant.
Okay.
And this explanation was brought to you by Whoppers, the original malted milk balls, with 25% less fat here in America. Whoppers.
Hope you understood that. Enjoy, girls. We'll see you next week. Bye.
Bye.